Let's 3D print some spacers to help replace the inner fender on my C5 Corvette build. Thanks for tuning in, everyone, to this video. I'm glad to be back after a little bit of a hiatus because of all the craziness with my house and the kitchen remodel that is still going on. We've got probably another 3 weeks left to go before it's all back together completely, but I'm glad to be back slowly doing videos again, making progress on my projects and the Corvette build, of course. So the plan for today, the thing that I've been meaning to do for a while now, is I want to 3D print some special spacer tools that will help me replace the inner fender on my C5 Corvette. Now, some of my last videos before I took a little brief hiatus because of all the house craziness had to do with me ripping the old damaged inner fender off of the Corvette. And in the process of doing that, I took some really detailed measurements of the spacing of the between the frame and the fender, because GM actually, what they do, if you haven't watched my previous videos, is they literally glue this inner fender to the frame of the car. And they use the panel bond adhesive as basically a shimming tool. Now, when the Corvettes were going down the production line, they probably had some special jig or fixture that precisely positioned this inner fender into the exact location to get all the right panel gaps. I obviously don't have that jig or fixture that they used, so what I did was I took measurements of the thickness of the panel bond adhesive in multiple places around the fender, and basically what I'm going to do is recreate those thicknesses with little 3D printed blocks. They're very simple tools. I'll show you guys in a second. I'm literally printing boxes, but because I can adjust the thickness of these little 3D printed blocks, it'll help me set the gapping of the inner fender to hopefully as close as to what it was coming off of the factory assembly line. Okay, so welcome everyone to my new ultra widescreen monitor setup I have here in my home office. I'm so stoked to have this new monitor because it comes in real handy when I'm doing any kind of video editing work or mostly CAD work, whether it's for my full-time job and I'm doing CAD projects for 3D printing projects at work, or obviously when I'm doing stuff at home as well. So what I've got here is the very simple tool I was talking about. This is literally the little box that I'm going to be using as a 3D printed spacer tool. Now, I know it's kind of hard to tell scale-wise how big this thing is, but basically this is a 1/2 inch box, and then the height of this box here, basically looking at it this way, is what's going to set the spacing for the inner fender. Now, this is number 1 of 9 different size spacers. Now, all the spacers are a 1/2 inch in their profile, but the height is different based on where it goes on the fender, and that's based on the measurements that I took from the thickness of the adhesive that was used on the old inner fender. So this is number 1 of 9. Just for reference here, you can see this is number 6. And you can see how much thinner this one is. So basically what I'm going to do, I already have all of these exported as STL files over here. So then I'm going to import these into Cura, which is my slicing software for my printer over there. And then I'm going to print probably 3 or 4 of each of the different size ones. And then we'll have those printed and we'll get them mocked up on the new inner fender for some fit checks. Okay, so I got 4 of each of the 9 different sized spacer blocks set up on the build plate in Cura here. So again, this is the slicing software. I do plan on doing more 3D printing videos to kind of basically explain the basics of 3D printing and what I'm doing here for those that haven't dabbled into 3D printing yet and are interested. So this is basically where you get your model set up to print on your printer. So what I got now is I set the material for PETG, which is the material I'm going to be using because it's definitely more heat resistant and a little bit more resistant to the elements compared to your standard PLA. For those that don't know, PET or PETE and G is a different variation of the plastic polymer, but it's basically what you find in your single-use water bottles, like your Arrowhead bottles and whatnot. So now what I've got here is my little booklet with all my preferred settings for each material. So I'm going to punch that into the material settings window here, or the print settings window, and then save it to my SD card, and we will go on over to the printer. So we've got the file loaded up on the SD card, selected it on the printer interface here. We got the PETG material loaded up and ready to go. I actually just found these, I remember I did a test print a little while ago. So these are basically what these things will look like when we're finished here. So you can see I just printed two. So this is number 1 and this is number 2. So these are basically the most basic thing you can print. It's literally a block, but it's going to be so helpful when trying to mount this fender onto the car. So now we're just waiting for the printer to heat up here. It's heating the bed first to 80 degrees C, and then it'll do the nozzle or extruder to 240 degrees C. That's kind of like my optimal printing temps for this type of material. And one of the last things I like to do before the printer starts, first thing is I put some blue painter's tape down on this glass bed. For those that don't know, blue painter's tape is a good surface that you can print on because it helps with adhesion, because sometimes parts will pop off the bed in the middle of a print. And to kind of further aid that problem, I also like to throw just a little quick pass of an Elmer's glue stick down along the print surface. Kind of do it in a cross-hatched pattern, and it's purple now, but as it dries it goes clear, so it's not going to end up on the part. So once the printer's done heating up, it will start on its own, and I do like to just sit here and kind of watch the first few layers, since those are the most important to make sure that your bed leveling is right, your nozzle kind of gap to the printer is right, a bunch of other things. Make sure you get good adhesion, and a 3D printing term that I'll explain later in another video is your first layer squish. That's a really important thing that you want to make sure you nail to ensure that your print prints nicely and sticks to the bed. So we've got about a 10-hour print that we're about to start. It's pretty long for just a bunch of little blocks, but the reason is because I printed these at 100% density, so there's basically no infill, like cross-hatched infill pattern. I wanted these parts to be really beefy and strong, just because they're going to be the actual final parts that I glue on the car. So now the printer is just starting now because it's reached its optimal temp, and it's doing its homing position where it hits all the limit switches on the X, Y, and Z axes. And then it'll do a prime strip down the side, basically prime the nozzle, and then it will start. Okay, so I had to make a few on-the-fly adjustments based on how this first layer was going down, just related to the bed level and the distance from the nozzle tip to the bed. Each material that you print with has its own kind of quirks that it likes based on the material properties, and PETG has its own set of little quirks that I'll get into a lot more detail in a video completely dedicated to that. But basically, yeah, just made a few on-the-fly adjustments. It's printing pretty well. It's got that good first layer squish. So this will carry into tomorrow, obviously, because it's about a 10-hour print, and then we'll keep working. Okay, so the print finished. It finished in the wee hours of the morning, so they're all finished. They turned out great. So now you can really see the height difference between all the different ones based on where they go on the inner fender to provide the different amounts of spacing. So now what I'm going to do is I'm going to use my needle nose pliers and pull them off, and then I'll take any of the remaining glue and tape off, and then we'll get them prepped to kind of temporarily mount them to the inner fender for the mock fit check. Okay, so I got all of the 3D printed spacers off of the build plate and down here in the garage. So what I'm going to do next is I've got my handy dandy notebook over here, and this is where I wrote down all my measurements before, and then I've got the number that corresponds to the number on the spacer, and so I'm going to do a mock fit to the fender. So I'm going to take my hot glue gun and one of each of the spacers, identify where it needs to go again on the fender, and just put a small dab of hot glue to secure it on so we can do our mock fit check. So all 9 fender spacers are temporarily mounted to the fender, so I'll just show you real quick. So we got number 1 up under here, 2, 3, 4, 5, 6, 7, 8, and 9. So that should help us set the gapping, and I'm going to get it mocked up to the car here, and we're going to get it mounted in the front using the headlight bracket and mounted in the back using the firewall / bulkhead bracket. And we'll see how close we can get. And then the other thing I got, which I'll whip out here in a second, but I got some Cleco pins, which are like body fastener temporary holding pins. They use them a lot in body shops and also in aircrafts manufacturing and MRO work, since they're dealing with a lot of sheet metal. So the issue I was having was it was holding the fender fine in the back and front when I mock fit it before, but in the middle here it kind of wanted to fall back a little bit or fall away from the car. So what I might do is I might drill a hole here and a hole here, and then you know, a corresponding hole here and hole here, and then use a Cleco pin to temporarily hold it in place to see how close we can get. So just in case you guys have never seen a Cleco pin before, it's a pretty cool little tool that is basically like an extra set of hands when you're working on stuff. So these are the Cleco pliers that kind of expand the pin. So here's one of the pins. Common sizes that they come in are 3/16 and an 1/8, and so I have both in the kit that I got that I'll show you guys in a sec. So you just use the little front part of the pliers here, and then you set it in place in the little recession, and then you push on it. That expands it, so that allows you to put it in, and then when you release, it pulls this little pin back as it expands out, and then it holds your sheet metal or body panel piece in place. So I got a bunch in the kit I got off of Amazon. So you get 25 of each size. So this is 25 of the 1/8 inch and 25 of the 3/16 inch. So it really comes in handy. It's kind of funny. They look like bullets almost for like a 5.56 or 223. So yeah, so you just use this, and it helps to kind of hold things in place while you're working on your car. Alrighty, ladies and gents, so here is the results of the mock fit check for the inner and outer fender on the Corvette. Now it looks pretty dang good, but it's not 100%. There's some fine tuning of some of the panel gaps that I need to do, you know, in the next video when I'm actually mounting this thing on, but it's pretty dang close. And just for a mock fit check, it only has like 2 of the 9 bolts that mount the fender into the car right now. So because of that, you know, there are some areas that need some fine tuning. Kind of on the front here, the hood needs to be brought up a little bit. Like there's little bump stops that the hood rests on when it's closed in the front and back. Those need to be adjusted a little bit. And then on the back here, this point down here, kind of on the rocker panel area, needs to be pulled in a little bit, which will help. That will hopefully be done when I put all of the panels in that mount the kind of inner wheel well to this outer fender. So it's not 100%, but it's pretty dang good. It got me in the ballpark, just to know that we're going to be close, and that my 3D printed spacers are going to do the job. Now I wanted to just preface that if you are doing this to your C5 or C6 or C7, you're going to need a lot of patience, because it can be very frustrating and very irritating at times trying to set these body panel gaps. And this isn't even the final set point. This is just a rough fit check. You know, it's one of those things where you kind of adjust the front and then it throws the back out, and then you adjust the back and then it throws the front out. So it takes a lot of patience. Don't rush it, you know, so you want to just make sure you do it right, so that it looks as best as it can in the long run. So like I said, this was just a very rough fit check to double check and make sure that my 3D printed spacers and my measurements all kind of got us close and in the ballpark, and I'd say that's pretty dang true. So as long as I mount the inner fender using the front headlight bracket and the rear firewall bracket, I think it'll get us pretty close. I will probably have to use those Cleco pins in the middle, because for some reason it wants to fall this way. It's just a really awkwardly shaped piece. So this is definitely an awkward job to do. It takes a lot of patience, like I said. So just have patience when you're doing this. So what I'm going to do off camera is I'm going to take all the spacers off of the fender that are on them now, since they're just temporarily hot glued, and I'm actually going to permanently epoxy them to the inner fender to prep for actually mounting it permanently on the car. Alrighty guys, so that's going to do it for this video. I'm glad to be back making videos again, even though the house craziness is still going on inside. Like I said, we've got probably till about the first or second week of June before that's all wrapped up, but I want to start making slow progress back on my projects again, because I want to get this thing back out on the road. I want to enjoy it and drive it and have fun with it, because that's ultimately what a car is for. But yeah, I hope you guys enjoyed this video, maybe learned a little bit about 3D printing through the process of me making those fender spacers. But like I said earlier, I'm going to be doing full videos completely dedicated to talking all things 3D printing coming in the future here, because it's a huge passion of mine. I just love it. I do it for my full-time job, so it's really cool to be able to talk about it on the channel and also incorporate it into my car projects and in the future my go-kart projects too. So if you guys have any comments or questions about 3D printing or the build or anything like that, feel free to leave them in the section below and I'll be happy to answer them. So thanks again guys for watching. If you haven't already, definitely subscribe for a lot more content to come. The next video on this build will be permanently panel bonding the inner fender to the car so we can get this thing all buttoned back up, or at least one step closer. So thanks again guys, and other than that, I will see you in the next one.